Hi everyone, this is Brandon from the Blockchain Institute, and today we're going to go over how to make a Helloworld smart contract in Solidity using the Truffle framework. Let's get started by installing Truffle, and you can do this by using npm install Truffle. So the next thing we want to do is to create a directory for our Hello World. So to create a Truffle project, you start with Truffle init. Truffle is based off the Mocha framework, if you're familiar with JavaScript. And it allows us to easily compile, deploy, and test our smart contracts. So if you check what we got in our directory, we have a contracts directory, a migrations directory. This will handle deployment, and a test directory, along with some configuration files. The editor I'm going to be using is Sublime. There's a good Solidity plugin that you can download for syntax. Okay, cool. So let's start first by just running truffle tests. And what this command will do is it will compile all of our smart contracts. Obviously, we have none right now. Deploy them to a specified network. Test will deploy them to a local blockchain and run any tests that we have in our test directory. So hopefully all of this is working. Cool, so let's write an initial test. So we have a new file, we'll call it test.js. Now tests can be written in Solidity, but most tools in Web3 are written with JavaScript, and it just makes it a lot easier to test. So here is our first test. If you're familiar with JavaScript, this will look very similar. Describe is the same thing that you'll see in frameworks like Mocha. And let's just get a basic test to work. So should assert that 1 equals 1. So if we wrote everything correctly, this test should pass. Okay, cool. Now, something that this contract function kind of gives you is you can pass it in accounts, and these are Ethereum accounts. By default, on SpinUp, it'll create just some fake accounts with fake Ether. Truffle gives that to you for free. So maybe let's just do a console log and see what this accounts object is. Oops. Okay, cool. So check out what it printed out. These are all the public addresses of the accounts given by the accounts object from this contract. Let's actually look up and see what that is. So Truffle. All right, start again. So now, these test accounts aren't associated; they're just spun up at runtime. But if we wanted to debug, this wouldn't be very useful. So there is a local blockchain that we can run. It's called Ganache. So, and you can install it just by typing in Ganache Truffle. It'll be the first link. And here's where you can download it. So I already have it installed, so I'll start it up. So it is running on port 7545, and it'll give us all these accounts right here. So the way to configure a project to talk to this blockchain instead of creating random accounts on test is you go to your truffle.js. And here's where you can configure all your different networks. For right now, we'll configure to the local blockchain, but in later videos, we'll show you how to deploy to Ropsten, a test network, and eventually the Ethereum main network. So we do this by setting networks and call it development. This should be the default config on your Truffle or on your Ganache client. So typically this network ID signifies which network, like if, for example, Ethereum mainnet usually goes by the network ID 1. The Ropsten test network goes up by the ID 3. But for now, we'll just do a star, and this will just match any network ID. So now if we run Truffle test again, then the printout we should see are these accounts right here. So I just copied this from a test project. This is all boilerplate code. So as you can see, 1D998 matches the account for here, and notice that we deployed a migration contract, which we haven't gone into, but so that cost a little bit of ETH, and this was the deployment contract, the deployment account. By default, it always selects the first account. Okay, so now that we can see we're connected to the local blockchain, let's actually create a contract. So we'll call this helloworld.sol, and sol is the extension for Solidity files. Every Solidity file starts with this line, and essentially what this line is telling the compiler is which version of Solidity to use. This caret right here indicates to use 0.4.23 and up. If we got rid of this caret right here, it would say only compile with a compiler that is 0.4.23. So we start out a contract. Contract is analogous to like class in an object like Java or C++. And a constructor is just called constructor. Okay, so that's a basic skeleton of a smart contract. So let's just run Truffle tests to see if anything happened, changed. So as it didn't, the contract compiled, you see here, but it was never deployed. And the reason for that is you need to write a migration. You see, this migration.sol that you get for free when you do a Truffle init, this contract is just basically keeping track of your deployed contracts with your project. So for instance, if you're upgrading your project, this migration would help you manage that. So we need to add a migration for every single contract. So let's create a new migration file, and we will call it to_contract migration.js. And we could pretty much just copy what's in here, call it hello world. Okay, so now we should actually see the contract being deployed when we run Truffle test. So we can go to our blockchain and actually look at the transactions. We'll run it one more time. So right now there's 8 transactions, and when we run Truffle test, we should see at least 2. Okay, so we got 4. We got 2 contract creations and a contract call. So that means that our Hello World is actually being deployed to the blockchain, running locally on our device. So at BIT, we like to push test-driven development, which means that we write our tests before we actually write our code. This makes managing more complex projects a lot more manageable. So this Hello World application, let's say we want to be able to set a phrase and we want to be able to get that phrase back. So how are we going to do this? Let's create a new describe. Let's call it phrase test, because we're going to be getting and setting and getting a phrase. So it should be able to set a phrase and store. So we will just say hello. So we have this hello world smart contract, and we want to set the phrase. There'll be a function called set phrase, and call this and we will So this will be the general flow. We have this expected phrase which we'd like to set using our smart contract, hello world, and we will get the phrase, and this will be our actual, and we will assert that the expected equals the actual. So let's just run test. We don't expect anything to pass because we haven't written the functions, obviously, but let's see if we get any other errors. So hello world is not defined. In this contract migration, we are actually exporting this hello world that makes it available for our tests. So what we have to do is we actually have to import this abstraction, and we do this by saying we use the artifacts.require. Call this hello world. And of course, this hello world is what we are exporting right here. Okay, cool. So let's see if this runs. Cool, so we actually got past this hello world is not defined, and we actually have a new error, and it's that set phrase is not a function, which obviously it's not. So let's go ahead and let's write that. So in this contract, we will need a string as our phrase. And the way you declare a function is function set phrase plus new phrase. Okay, and simply we just want to phrase is equal to the new phrase. Oh, and you need to close each declaration with a semicolon. Also, you need to specify which type of variable this new phrase is. Okay, so okay. So the reason why we're still getting this error is what this hello world is. It is an abstraction of the contract. It's not the actual contract itself. So to get the actual contract, we need to get an instance, and we do that by like saying let get instance equals hello world dot at, and we have this hello world dot address. So what this instance is the actual contract on our blockchain. Also, this is an asynchronous function because we do not get it. Oh, I'm spelling this wrong. So this async function, all it is saying is an async call is meaning something that's not returned immediately, and that's with anything that you need to go out and actually communicate with the blockchain for. So we can do this by saying await, and what this line does, it says, go get me hello world at this address, and I'll wait for it. And once it waits for it, once it gets it, it continues execution. Cool, so it looks like our set phrase actually ran, and now we're actually getting an error on get phrase, which we did not write. And actually, with any global variable where you just need to read from the blockchain, you can just wait for it and get that variable directly. So you can just say something like instance.phrase, and obviously we have to await for it to read the blockchain. Okay, so we're getting this error because do not make this public. With any public variable, you're automatically able to read it. So hopefully this will fix the error we had. Cool. So what we were actually able to do is we created a smart contract. We deployed it to our local blockchain using Ganache, and we wrote a test to demonstrate that it works using the Truffle framework. So that's it for today. Thanks for watching, and more videos to come.